In question 7, part 1, it says that by first expanding cos theta plus sin theta, we have to find the three solutions of the equation cos theta plus sin theta whole square equals to 1. Now, expanding cos plus sin whole square, I'll be using C and S in place of cos theta and sin theta. So, expanding cos plus sin whole square, we'll get cos square plus 2 sin cos plus sin squared equals to 1. So now we can see that cos squared plus sin squared, we can use the identity as sin squared plus cos squared is equals to 1. So we can write it as 2 sin cos. Well, there is no square over here. So this will be 2 sin cos plus 2 equals to 1. And 2 sin cos, and this is a 1 over here. So this will be 1. So 1 minus 1 will become a 0. So we can write it as sin theta equals to 0 and cos theta equals to 0. Now taking sine inverse of 0, we'll get one of the answers as 0, and cos inverse of 0, the answer will be pi upon 2. Now from 0 to 180, as the limit is from 0 till pi, we know that if one of the answers for sine theta equals to is 0, another answer will be sine of pi, as sine of pi is also 0. So the three values of theta will be 0, pi upon 2, and pi. In part 2, we have to verify that the only solution of the equation cos theta plus sin theta is equals to 1 are 0 and 1 upon 2 pi. So to verify this, we'll substitute first of all 0 in place of theta. So we'll get cos 0 plus sin 0, and it should be equals to 1. So cos 0 is 1 and sin 0 is 0. So as it is equals to 1, it is one of the solutions. Substituting sin 1 upon 2 pi in place of theta, we'll get cos 1 upon 2 pi plus sin 1 upon 2 pi. And as cos 1 upon 2 pi is 0 and sin 1 upon 2 pi is 1, so this will also be equals to 1. So it is verified these are the two solutions. Now taking sin theta is equals to pi, we'll get cos of pi plus sin of pi equals to 1. Cos of pi is minus 1 and sin of pi is 0. So as minus 1 cannot be equals to 1, it means that pi is not a solution, which means that the only two solutions are 0 and 1 upon 2 pi.